Greetings and welcome to SpaceWeek Live for Sunday, December 27th, 2020. Welcome. We had a pretty minimal, well, we're in holidays here, so pretty minimal week last week. Not much going on this week. A couple significant events that we can talk about here. So first of all, Merry Christmas, Boxing Day, Hanukkah, etc., to everyone. I've got my sloth, oh, nice, translucent green, my sloth sweater that I got for Christmas from my sister, as well as my giant 3-pound Hershey's bar. I've taken a couple bites of it. I'd rather have a giant Hershey's bar than a giant candy cane, though, because you can at least easily break pieces off the Hershey bar. But, yeah, so let's see. Let's start with the Great Conjunction. So I've got to queue up an image here. Let me switcheroo to the old browser-rooney. So Jupiter and Saturn, while not any closer to each other than usual, appeared closer together in the sky last Tuesday than they have in approximately 400 years, and at night, when we could actually see them for the first time in 800 years. So let me go ahead and pull up my photos. I did the best I could. I had my 600 millimeter lens on my DSLR, and all right, here, boop. So, yeah, this is the best I could do. I do not have a telescope. I just have a camera with a long lens on it, but you can clearly see that Saturn has rings, and Jupiter is, the thing is the brightness, the relative brightness of Jupiter and Saturn are different enough that you are not going to get both of them properly exposed in the same image, just like you can't get a sunlit spacecraft and the stars in the background properly exposed in the same image. So Jupiter's actually overexposed here, but I need to work on my technique. I have my star tracker mount, but it's difficult to work with, and I'm not sure that it's as steady as it needs to be, because like maybe I need to upgrade my tripod or something. But in any case, so there's Mars and Saturn, Jupiter and Saturn, and then with a little slightly longer exposure, you can actually see the 4 Galilean moons of Jupiter: Io, Callisto, Ganymede, and Europa. And I'm not sure in which order they're in as we see them here. I'm finding that focus is also, like getting a sharp focus at night with almost nothing to focus on, is very difficult, because through the camera you can barely see the stars. They come out in photos because of the longer exposures, but you can focus on the moon, but again, yeah, so focus is a challenge. Plus I had my lens doubler on there, which may be introducing some bokeh or fuzziness. But then I took a picture of, this was cool. So I was talking with my neighbor, and while I was talking with my neighbor, he was on the phone with his son telling him about the conjunction. And right before my eyes, I was looking right at Jupiter and Saturn, a meteor streaked right in front of them. It was amazing. It was incredible. And I wasn't taking a picture at the time, but I saw it with my own eyes. And I only saw one other meteor that night, and it was while I was taking a picture of the Pleiades star cluster, otherwise known as Subaru, the car brand, They were named after the star cluster. And here we have a meteor. That's not a satellite or a plane. It's a meteor. Streaked through the photo, so I got lucky with that one. And then there are my star trails. So I set up my camera to take 30-second exposures for all night, basically. And they lasted I should say my memory card lasted about 6 hours, and then it filled up. But my camera was still good. I wrapped a looks like an ankle warmer. It's a strap with Velcro on it that you plug into a USB power source that actually heats the front element of your camera lens to help keep the dew off of it, the condensation from being outside at night. And unfortunately that ran out of power, and it was also freezing temperatures on the 21st, 22nd. So when I went out to get my camera in the morning, the lens was like frosted over. It actually had frost on it, so I had to warm all that up. But anyway, yeah, so this is a stack of about 707 images. Now, there were airplanes that got in the way. There were about 31 of them, or at least 31 images that had airplane streaks in them, and I had to remove those for this composite. But so obviously, well, maybe not obviously, but if you're not familiar with star trails, what we're looking at is a manifestation of the revolution of the Earth. So as the Earth spins every 24 hours, it spins around an axis. And that axis, if you drew an imaginary line through the axis of the Earth up into the sky, it would almost exactly intersect with Polaris, the North Star, which is at the center of this swirl. And it's not quite like if you look at the North Star, it moves a little bit, just a little bit, but it's basically within a very small fraction of a degree dead on to the axis of the Earth currently. Although Earth's axis does actually change. It processes over a period of something like 40,000 years. And so in, I don't know how many thousands of years, our North Star will actually be Vega rather than Polaris. But yeah, so there we go. Now, that was the Great Conjunction. So although Jupiter and Saturn, I should say Jupiter catches up with Saturn because, as you probably know, closer orbits are faster than farther away orbits, and so Jupiter orbits the Sun faster than Saturn does. Therefore, Jupiter catches up with Saturn in our sky from our perspective about every 20 years. But they're not always nearly as close as they were this past solstice, the 21st. The next time they'll be approximately this close will be in, I think, 2080. So if you're still alive, check them out. And then 11 years later, make sure to check out Starman when he comes back to Earth, close to Earth. So as far as launches, there was only one last week, and that was a Chinese Long March 8 with the XJY-7 satellite. And I believe this was the first launch of a Long March 8. They also had another first launch this year of the Long March 7, which failed to reach orbit, but that was like way back in February, I think. But here, let's check out the Long March 8. And there you have it. That was the Long March 8. Oh, also, yes, there was one other big event last week, and it was not a launch. It was the Starship SN9, rolled out to the from the high bay to the launch pad. Let me find Lab Padre here. So if you recall, after the spectacular Starship SN9 launch a couple weeks ago, the SN9 vehicle, which was in the high bay in the ship, or the, what do they call it, the shipyard, it tipped over. The stand collapsed and it tipped over, and it was leaning against the side of the high bay, and that caused some damage to the forward and the top and the bottom aerodynamic surfaces, the fins that pivot to control its belly flop descent. But they fixed that. They mounted 3 Raptor engines on the vehicle, and then they rolled it out to, here we go. They rolled it out to the launch pad, which I will show you now, courtesy of Lab Padre, who I will also, someone please link Lab Padre in the chat, because I'm controlling this thingy here. Hey, there's my voice. I think I was speaking while muted. Yeah, so here we have SN9 rolling very quickly at breakneck speed out to the launch pad. The actual process was much slower than this, but now that's no crawler they have like the crawlers they have at Kennedy Space Center for the space shuttle and for Saturn V, and I don't know what other vehicles the crawlers might have been used for, but it gets the job done. Rolls it out to the launch pad, where they have their, what do they call the crane? Bluto, like the Disney character. So again, this footage is courtesy of Lab Padre. They have 24/7 coverage of the goings-on at the SpaceX launch pad and rocket assembly yard at Boca Chica, Texas. You should definitely check them out. I thought it was really cool, like when you watch them lift the rocket with these cranes, they're lifting the whole rocket from the nose cone. Like, they're not putting the straps underneath the bottom of the rocket. They're actually attaching to the nose cone and lifting the whole rocket from the nose cone, which is quite impressive. Now, obviously, it's not fueled, so it's not going to be nearly as heavy as it would be at launch, but it's still 160 feet of stainless steel goodness. So, yeah, that is neat. Thank you, Lab, for that. So, looking ahead to the next week, let's see, what do we got? We have one launch, exactly one launch scheduled for the next week. The last rocket launch of the year, unless somebody else sneaks one in. And that is on Monday, December 28th, that is tomorrow, at 11:42 a.m. Eastern, 4:42 p.m. GMT, and Arianespace Soyuz will lift off from the Guyana Space Center with CSO-2, the second of 3 new generation high-res optical imaging satellites for the French military. So, yes, that's the only launch this week. No other spacewalks, ISS departures. Now, NASA did drop a new date for the Cygnus NG, what was it, 14, whatever, the Cygnus departure from the space station, but that's not until next week. So I'll cover that next week. Now, I thought it would be interesting to take a look, since we are, in fact, at the end of the year, the year to end all years. 2020 has been a doozy for everybody, but it was very eventful in terms of spaceflight. I mean, eventful otherwise too, but in any case, I thought it would be fun to take a look at some of the numbers for 2020. So we had a total of, well, according to Wikipedia, we had a total of 112 launches. I think those are only orbital launches. If you include the suborbital launches, there've been about 160 launches overall in the world. The majority of it, well, as a country, the United States hosted more than China, but from a single launch provider, China had the lion's share with, you know, the vast majority of the Chinese launches being provided by whatever the name of their space agency is. SpaceX comes in at number 2, far and away above any other entity, including you know, Russia, Roscosmos, or you know, ULA. Now, bear in mind that the United States numbers also include Rocket Lab, because even though the Rocket Lab Electron, because even though Rocket Lab was founded by a New Zealander and they launch from New Zealand, and their presenters are by and large New Zealanders, it's actually based in the United States. So they actually assemble the Electron rockets at a facility in the United States, and they ship it back down to New Zealand. They probably did that for like security reasons, so that they would, because the a United States-based company, they can get into the lucrative, you know, government launch contract business, like the NRO launches. But anyway, and similarly, the Arianespace Soyuz numbers are also included under Russia, not France, even though Arianespace launches from, well, is a French company, and they launch from French Guiana, which is actually part of France. It's not just a territory. It's actually like a state in the United States, which is, it's kind of a unique status. The rockets still count as Russian, which is weird, because the way they have this categorized, you see Europe hosted 5 launches. Well, Europe includes, you know, Vega, it includes Ariane 5, but it does not include the Soyuz, even though Arianespace launches them. So, whatever. Yeah. You can twist numbers however you like. As far as rocket platforms or rocket vehicles, we've got Long March, which is kind of like the Ford F-150. Every Chinese rocket is a Long March something. You get the Long March 5, Long March 7, Long March 8, Long March 4B, E, Long March 4C. So a lot of Long March rockets. And then the Falcon, of course, the Falcon 9. There were no Falcon Heavy launches this year. There was, so of the total of 25 Falcon 9 launches this year, 9 were reused boosters, and 5 were new boosters. So that's definitely heading in the right direction. And there may have even been boosters that were reused more than once this year. I don't specifically recall, but they also made, SpaceX also reached some milestones as far as reuse of parts. I think they reused a booster for the, what was it, the 6th time or the 7th time for the first time this year. I think it was like 6th time, which is really impressive. So as far as spaceports, okay, these are broken out by country. Mostly the U.S. and China. I mean, you know, most rocket launches take place from Florida in the United States, of course. There's a very few from Vandenberg, and then a few different sites in China. You've got basically 3 or 4 main sites in China that they launch from. And then the Russian launches from Baikonur, of course, are actually launching from Kazakhstan, because back when that facility was built back in the 50s, Kazakhstan was part of the Soviet Union, which was Russia. So let's see, by orbit. Not surprisingly, the vast majority of launches are to low Earth orbit, although we had a few medium Earth orbit launches, which are typically going to be your GPS satellites. A handful, or about, how many? 18, 17 geosynchronous launches up to approximately 22,000 miles. That's the altitude at which you can basically hover a satellite over a given point on the ground. And that's very useful for both communications and Earth observation, weather, satellites, things like that. 4 heliocentric launches, which would be your science probes to the sun, or around the sun, and then 1 high Earth or lunar transfer launch, which I'm guessing that one was Chang'e 5, which went to the moon and successfully grabbed a sample of a couple kilograms of moon rocks and dust. So that is the year in a bloody great nutshell. Let's take a look at your questions to see what you have asked. All right. So, Chris V. Okay, Chris V is quoting Chris V, asking, what does one exposure layer of the composite look like? Oh, sure. Let me open up a new frame here. So, all right. So just a reminder, he's referring to the star trails. Let me get one exposure for you. So just as an example, this is what one exposure looks like. Yeah, it's just stars. And if I zoom in a little bit, they're not even like they're not even that well focused, because again, well, first of all, I was cold, and secondly, I have real challenges getting a sharp focus at night, because you can't really see the stars through the viewfinder. Like you can barely see, like the brightest star, you can barely see it through the viewfinder when you're at a wide angle. Like if you zoom in, maybe you can see it, but the star trails, you want your view to be as wide as possible. So this is looking roughly north. Down here at the bottom, maybe, a little bit to the right of center is going to be Polaris. You can't see it in this image because it's slightly out of frame. But I need to work on my focusing techniques, and I think I actually need a new lens, a new wide lens, because the one I have is the stock one that I got with the camera. It's about 10 years old, and it's like there's a plastic ring that's loose on it, and it like rattles around. I tried to glue it in place, but the lens has seen better days, and I think that its focus is inconsistent across the frame. So, like in the middle, the stars are, roughly focused, but then toward the edge, they're a lot blurrier. Plus, I don't know if you can see it, but there's a red dot here between these blue stars on the left side. There actually were quite a few, well, there are a few hot pixels, that is permanently hot pixels, on the sensor that have been, damaged or just lost over time. Yeah, I mean, it's an old camera, so it's seen a lot of use. And plus, this was the camera I used for much of my professional photography, which I don't do much anymore, but, it's had, I don't know, maybe 100,000 exposures on this camera. Now, I also want to show you so I had some fun with the star trails. I applied a radial blur to it. Almost centered at the, because Polaris is actually out of frame, but I almost centered it at Polaris, and I just like the effect. It's a cool effect. It's almost soothing or mesmerizing in a way. Kind of looks like the surface of a vinyl record, or the rings of Saturn. But so because I had focus issues, I actually had an idea that it would be cool or fun, interesting in any case, to deliberately blur the photos, like to blur the heck out of them, and then take a time lapse or an image sequence and see how that looks. It just could be like, I'm thinking it could make for a really interesting sort of abstract photo, just for fun. So here, let me show you a photo of a plane trail. This is ridiculous. So most of the airplanes, they leave these fairly dim sort of whitish streaks across the image with periodic red dots which represent the blinking light on the plane. But this, I don't know if he was flying extra low or like what, or shining his headlights at me, but this one streaked across the frame like a I don't know, something that streaks. So yeah, there were 31 of these plane streaks that I had to remove from the original images in order to create the star trails stack without a bunch of, junk in it. There were also, I also had to nudge a couple of the photos because like the camera got bumped or something and the stars weren't quite aligned, and you can see it, like you notice that something looks off in one of the pictures. All right, back to questions. Sorry. Let's see. Mark. Sorry. Got a emergency Amber Alert. There's means a child was abducted or something. But I'm sitting at home, so there's no chance that I will spot that Chevy Malibu. Let's see. Mark Desert, could you explain more about the star precession? I know the ancient Egyptians had another North Pole star. Yeah, so typically, I wish I had little props for demonstrating. But so the Earth is tilted at whatever it is, 23 degrees. And imagine that this, I don't know. Imagine that this can of Coke Zero is the sun. So the Earth goes around the sun. The Earth's angle doesn't change, which is why we have seasons. So when it's on this side, the southern, my fist side of the Earth, the southern side of the Earth is facing the sun, and so they get summer. When we're on this side, the tip of my finger, the northern side of the Earth is facing the sun, and so we get summer in the northern hemisphere. But there is the yearly angle doesn't really change very much, but there is a slight wobble in the orbit of the Earth, like where the angle kind of changes like this. And as it processes over the course of about 40,000 years, so this is over many, many, many revolutions around the sun. So over the course of 40,000 years, it makes one full revolution of its wobble. And so what that means is the axis of the Earth points at different stars over the course of those many thousands of years. So, right now it's pointing at Polaris, but in some thousands of years it'll be pointing at Vega. And in some thousands of years after that, it'll be pointing somewhere in between the stars. What that means is that in different epochs of the Earth's existence over the long haul, the seasons change too, because as the axis of the Earth changes, the orientation of the hemispheres with relation to the sun is going to change as well. So if the Earth is pointed more closely to 0 degree inclination, then, and I don't know what the actual, like, the number of degrees in the difference in the Earth's wobble is in the Great Precession, but the closer you get to vertical, the less pronounced the seasons will be. The farther you get from vertical, the more pronounced the seasons will be. So I don't have a lot of details regarding the precession beyond that, but would be an interesting topic for a video, because and it is true that a few 6,000 years ago, when the pyramids were built, or whatever it was, they did have a different North Star, and there's not necessarily any north. Like, it could be, the Earth's axis could be pointed at just blank space where there's no noteworthy star. But all right, Maria Kutujan compliments me on my photography. Thank you. I do what I can. I'm out of practice, and I need to work on it. But my astrophotography techniques are not very finely honed. Mark Desire, how many SNs are SpaceX building simultaneously, and how many of them can be expected to reach at least 100 kilometers altitude or reach orbit? So I guess the first question, how many are they building simultaneously? I mean, if we look up let me see if they list the SNs here. Prototypes, Starhopper, high altitude prototypes. I don't have like a list of the SN, the Starship serial numbers handy, but so when they tested SN8, SN9 was basically ready to go, and they've got at least a couple more that are in various stages of construction, and I think they've actually started putting together Falcon Heavy as well. But so at least a couple. But now that SN8 is blown up and SN9 is on the pad, I don't think there are any other completed starships waiting in the wings. But I could be wrong. Again, I'm pretty busy. I don't have a chance to check all these things. But and your second question, how many can be expected to reach at least 100 kilometers altitude? That will depend entirely on decisions made at SpaceX regarding the development and testing timelines. Let me bring this over here so I'm not looking off to the side. I'm kind of sort of looking at you. Yeah, so as far as which SNs they will launch and to what altitudes, I mean, SN8 went to 12.5 kilometers. I don't know if I don't know what their plans are. The thing is, they're not entirely transparent with their intentions. I mean, Elon posts, teasers here and there, but there's not a lot of information from SpaceX as far as what their game plan is. With Starship development, it's almost always a sort of wait and see scenario. So, and I don't like to count chickens before they're hatched, or, and the fat lady ain't singing yet. So, I would say, I mean, it's technically possible for them to reach orbit with SN9. I don't know if they'll go for that, or if they'll try another high altitude test. But maybe they'll try another high altitude test and see if they can, land it successfully, and maybe then they'll do an orbital launch. But we'll just have to wait and see. Football Ian says there were a lot of first launches this year. It was a pretty eventful year as far as rocket development. Mark Desire, timetable. When is the first SNSH planned to reach orbit? Just discussed that. I would think, and this is a total swag, a total guess, but I would think maybe spring next year, maybe mid next year. Again, it depends on how aggressively SpaceX pursues their development timeline. Roger C. Check Sci News again. Chinese extra launch. Oh, they snuck in another one, huh? Yeah, China's been launching like crazy this year. Snow Kittens. No Falcon Heavy, so Delta IV Heavy was the most powerful rocket of the year. Yes, that's correct. Delta IV Heavy was the most powerful rocket until Falcon Heavy came around. The most powerful rocket in current operation until Falcon Heavy came around. The space shuttle was much more powerful, and so was Saturn V. But as far as currently used rockets, yes. So last year, the Delta IV Heavy NROL-44 launch was the most powerful rocket launch, even though it took 14 tries to get it off the ground. Football Ian, have you taken photos of any meteor showers? I haven't, because I never have good luck with meteors. Like, I go outside and I freeze my butt off, and I may see one or two, but I've tried taking photos of them. I've set up my camera at least twice to take, like, the reason why I took those Star Trail photos is because I knew that there were meteors around and I wanted to capture them. But even though with my own eyes I saw the meteor that flew in front of Jupiter and Saturn, and I saw the meteor that flew by the Pleiades, despite the fact that my camera was taking pictures every 30 seconds for 6 hours, I didn't catch a single one in my Star Trail photos. I didn't see any satellites, even. I didn't see any meteors. Maybe my exposure settings were wrong. I don't know. But night photography is difficult. It's very tricky. So no, I don't have any photos of meteor showers. Crystallina Bacteria, thank you, Raw, for all your videos this year. You've made life a lot easier for a lot of people in the middle of this pandemic, and I've learned so much. Those are much appreciated words. Thank you. I'm glad to be here for you. And I am actually working hard for you well, not at this very moment, I'm just talking, but I'm in the midst of assembling a compilation of all 2020 launches. It's going to be a big one, because there were, like I said, about 160 launches. But I'm partway through March, at which point my computer crashed last night and I lost some work, and I was like, you know what, screw this, I'm going to play a game. So in the middle of the night, I played Halo. But once I get back to it, hopefully I'll be able to finish it up by the end of, by New Year's, so that I can release the 2020 rocket launch compilation video on time. If not, it'll be shortly after, hopefully within a couple days of the new year. Let's see. Comment on my photos of stars. Snow Kittens. Fourier, transform that boy. I'd have to look up what the heck that means, so I has the dumb today. I don't know what you mean by that. Maria Kutujan, in the south hemisphere we have Canopus star. Yeah, that's only, I don't remember, well, I know that Canopus is near the southern pole, the southern celestial pole, but I don't recall how far from it is. I think it's, well, if it is your pole star, if I recall, it's a lot dimmer. Here, let's ask Wolfram. Wolfram, Canopus, magnitude. Wolfram's being slow. Negative 0.62. Wolfram. Polaris. Magnitude. By the way, Tassie Man, good to see you here. Always plus 1.97. Yeah, okay. I'm not sure about this. So according to this, Canopus is a lot brighter than Polaris. I did not think that was the case. I don't know. I've never been to the Southern Hemisphere. I have never seen Polaris. I mean, I've never seen Canopus, or the Southern Cross, or the Magellanic Clouds, or Alpha Centauri, or any of that stuff, or Ophiuchus, or whatever your southern pole constellation is. So yes, y'all Southerners are spoiled for space. Plus, you have the Atacama Desert in Chile, which is the best spot on Earth from which to view the heavens. And that's why we have a lot of telescopes there. But a road trip. All right. So let me see if there are any more questions. Nope. All right. I think that will wrap it up for this year. That'll wrap it up for this week. And yeah, so thank you so much for sticking around with me. Watch out for that 2020 rocket compilation video. It's going to be a big one. And have a great new year. Keep it raw. And I will see you next time. You know what? Phantom on iPad asked a really good question, and I wanted to come back on here and answer it. So, we're back. Phantom on iPad said, "Why are stars so big?" And that's a great question, and I wanted to answer that. What is a star? A star is stellar dust and gas and material, mostly hydrogen, but stellar dust and gas that has gathered together due to the force of gravity, because gravity is exerted by all matter, and matter pulls matter. The more massive an object, or the more massive a cluster of objects, the more gravitational pull they exert. And so when you have these large clouds of gas and dust, over time, either due purely to their own gravitational pull on each other, the particles pulling on each other, or sometimes they can be kick-started by an external force, like, for example, if a star goes supernova, and the shock wave from that compresses regions of gas and dust such that they come together. You get enough gas and dust and material, and they start pulling each other in through gravity until they form a clump. Once enough material falls into that so there's an accretion disk around the formation of a star, which is basically a flat disk of spinning material, because basically everything in the universe spins. And so as that material gets pulled into this clump at the center, the gravity at the center gets more and more and more as more material gets collected in one place. And the heat and pressure generated by the sheer mass of material that has gathered together is what ignites fusion. because fusion can only happen under intense heat and pressure. And humans can recreate fusion, but only for very small, short periods of time. But the sun, because it's, you know, bloody huge, has, you know, it's a star, so it has ignited fusion, and that's what causes these hydrogen atoms to start fusing together to form helium atoms. You know, and the photons from the incredible energy that's released from that reaction, the photons that result from that reaction, flow outward from the sun and are emitted as light and radiation. I mean, you know, the solar wind. And so the reason why stars are big is because they are just huge collections of interstellar gas and dust. Because if they weren't so big, they wouldn't be a star. You know, you'd have, I mean, you could have a rogue planet that is gas and dust that gathered together, but it wasn't enough to create fusion. You know, but if it's not orbiting a star, then it's going to be dead and cold and silent, you know, floating in the universe. Jupiter's big, but it's not nearly big enough to be a star. It would need to be something like 10 times bigger in order to achieve fusion. That's what makes it a star, is when fusion is ignited. And here's an interesting thing. So the average density of the sun is, I think, only 1.4 times that of water. But the density of the outer atmosphere of the sun that we see, the photosphere, is it's essentially vacuum. Like it's, I don't know, thousands of times. I have a command here. Let's see, sun density. The outer layers of the sun are, you know, thousands of times thinner than our atmosphere. Let's see, 1.28 million times less dense than Earth's atmosphere. That is to say, the sun's photosphere is, in fact, a purer vacuum than humans can even create, despite the fact that it's incredibly luminous. But the core of the sun is 45 times more dense than diamond. So there's a huge gradient in the density of a star. Now, if you look at a star like Betelgeuse, which is a red supergiant, much, much larger than the sun, but it's not that much more massive. Like the range of masses that can be supported by a star is actually fairly narrow. You know, once you get more than about 20 or 30 times the mass of our sun, or maybe, you know, maybe more, maybe 50, maybe even 100 times the mass of our sun, then you get into the territory where you know, the star starts collapsing in on itself and creating a black hole or a supernova. And so the range of masses that are represented by the stars out there is actually fairly narrow, whereas the sizes represented by the stars is very wide. So you know, you have your red dwarfs that are much smaller than the sun. You also have your supergiants, your blue and red supergiants like Betelgeuse, that are many thousands of times larger than the sun, but are very sparse. You know, the average density of Betelgeuse is, again, mostly vacuum. So, yeah, stars are very fascinating. Like, stars, they trip me out. Anyway, I wanted to come back on to talk about that because I am not a cosmologist. I'm not even an astronomer, but I find stars just incredibly fascinating. Oh, hey, Bennu on my shoulder. I find stars incredibly fascinating, and And that's what keeps me going. I mean, it's so much interesting stuff out there when you actually start digging into it. You know, things are not what they seem. I mean, you see a star and you're like, hey, you know, and you think of it being like a monolithic object, like a single object, but it's very like, just like the Earth has a great amount of diversity across its, you know, surface and into its depths, so does the star. Anyway, goodbye again. Take care, keep it raw, and have a great new year.